So let's start looking at the exercises in Unit 3.4. Let's look at exercise number 3. The question is here, we're given that the radius is 20 centimeters. The angular velocity, which is denoted by omega, is given as pi over 12 radian per second, and time, or t, is equal to 6 seconds. Okay, and we are asked first to figure out the angle generated by this point in time t, or in 6 seconds. So the angle is going to be equal to the angular velocity times the time. Okay, this is the total angle subtended. So however fast the circle is rotating in terms of angles per unit time times time, that will give us the angle. So the angle then is equal to pi over 12 radians per second times 6 seconds. Okay, and that will give us the angles in radians. The seconds as units are going to cancel out, and we are left with the angle being pi over 12 times 6 radians, which is the same thing as 6 pi over 12 radians, or pi over 2 radians. Okay, so the answer for 3a is pi over 2 radians. Let's go to B. The distance traveled by P along the circle. Okay, so in order to figure that out, we have to do the sort of, well, actually, since we know we can actually do this directly. We know that we've traveled pi over 2 radians, and we know that the formula, the distance, or sometimes denoted as s, equals theta in radians times the radius. So we can now figure out s directly by taking pi over 2 radians times a radius of 20, and that will give us 10 pi. In this case, our unit for radius is centimeters, so this would be 10 pi centimeters. And C is asking us to find the linear speed of P. So the formula there that's important is that the linear velocity, okay, is equal to the radius times the angular velocity in radians. Okay, so let's just plug in what we need here. The radius is 20 centimeters, and the angular velocity we were given as pi over 12 radians per second. So our linear velocity, or v, is going to be equal to 20 pi over 12 centimeters per second, which simplifies down to 5 pi over 3 centimeters per second.